Hey, so carrying on in our differentiation series, today we're going to be looking at stationary points. So first just tell you what stationary points are. I've just drawn a line here on a graph and I've marked 3 points on here. This one here being a local minima, see the gradient here is 0, a point of inflection, again where the gradient is 0, and a local maxima where the gradient is 0. We say local because you could be looking at a section of a line and it might have a local maxima which isn't actually a raised point, because if I was looking at a section between say here and here, the maxima would still be there. That would be the local maxima between that section, even though it's not like the top of a hill kind of looking point. It's just the highest point in that place. So we're going to use an equation today, and we're going to use the equation of y is equal to x cubed minus 3x squared minus 24x minus 7. And the first thing you want to do is you want to differentiate this. So we have y prime, which is equal to 3x minus 3x squared, sorry, minus 6x minus 24. And what we want to do now is we want to say at this point now, this is our derivative, this is always equal to 0. So we need to say that this is now equal to 0 at a stationary point. And now because we're rearranging this to be equal to 0, we can divide everything by 3. Or we can just take 3 outside the brackets. So we'll just take 3 outside and we'll just say we have x squared minus 2x minus 8 is equal to 0. And then we want to factorise this. So we have a bracket of 2x terms, like I'm sure you've done many times before. So that gives us 3, do our brackets, is equal to 0, and what would this give us? X, and this will be a 2 and a minus 4 then. So we know that if x is equal to minus 2, this is all 0, and when x is equal to 4, then this is all 0. So these are our two x values. So we can have 2 points, point 1 and point 2, and they are minus 2 and 4. And to find the y values, I'm not going to go through, but just substitute these values back into our original equation, and you'll be able to find the y. There's no point wasting your time doing that. It's 21 and minus 87. I work that out to be. So these are our 2 points. Now, so how do we determine what to do with our points? So next thing you want to do is take the second derivative, so y double prime, or d2y by dx2, and this is equal to 6x minus 6. And then we're going to put our values for each of our points for x into this equation. So if we put in minus 2, we have 6 minus 2 minus 6, and this is equal to minus 18, and this is less than 0. And if we put another point, we have 6 by 4 minus 6, which equals positive 18, which is more than 0. And all you do is we say that this gradient is is decreasing in either end, less than 0, like there and there, so this must be a maximum. So I'll just put this here as max. And the opposite's true of this one, where it's increasing either way, so this is min. And I'll just quickly show you how to deal with a point of inflection as well. So if I was to draw a graph, and I'm going to do it for x cubed, like that. That's the graph of x cubed, roughly. And our point of inflection is going to be here on the 0. So that means we have y is equal to x cubed. Now if we take the first derivative of this and the second derivative of this, we're going to have 3x squared y prime and y double prime. Now you can see if you factorise this out, you're just going to get 3x x, so it can only be 0 when one of them is equal to 0. And for this is just 6x. And now at this point, this is going to be 0 here, So we can see that this is 0 at 0. So we can determine that at x equals 0 we have a point, and then we just sub the value back into there for y equals 0 cubed, and you'll find your point for this one. It's just at 0, 0. And that's how simple that is. You just deal with how you look at it, and you look to see that the gradient, if you insert any value of x on this, you can see is going up and any point is going down. If you haven't got your graph to draw, you could just try and put in any values of x. So if I was to put in here y double prime for 6 of 1, then this is obviously equal to 6, which means that it's going up. And if we were to put in for double prime of 6 of minus 1, say, then this is going to be equal to minus 6, and it's going down. So we can determine from that this is in fact a point of inflection. And then you can see, again, what I said there, that it has to be equal to 0. To be 0 for a point of inflection, substitute the value into our original equation, and you get the other 0 there. And if you want to see the last video in the series, just go ahead and click down there now. And I hope you enjoyed the video.